All right. Hey, y'all. Hope everyone is well today. I've got a new update. This is artificial neural networks, abbreviated ANN. Okay. And this is deep learning. Okay. So deep learning is like TensorFlow, PyTorch, CNNs, RNNs. We'll get into that in just a moment. But we're going deep today, guys. Deep on deep learning. Okay. So I did right there, just like tried to make a little joke. It's a little bit dry. Sorry, if you don't get the humor. I'm sorry, but trying to liven it up a little bit. Okay, so what is artificial neural networks and what is deep learning? Basically, we have an input layer and an output layer. So the data that's fed into the input layer is the input, right? That should be pretty straightforward. Should be pretty obvious. And the output is the final output. In between, we have a few different things happening. We have forward propagation. Data flows through the network from the input layer into the output layer. Okay, we'll see that in just a minute. There's a loss calculation, okay, and this determines if there's any errors in the predictions that we're making. The predictions in this case is going to be, we're looking at pictures and images and trying to predict what the picture is, and we're looking at documents and trying to summarize the document and do some kind of sentiment analysis. Is this positive, negative, or neutral, right? Which is neither positive or negative. We're doing backward propagation. This uses techniques that adjust the weights or the biases based on the error, and we're trying to improve the predictive capabilities of the model. And then there's iterative learning through multiple iterations, or epochs. This is what they're called. It's like a loop. We'll see that in a few minutes. The model tries to refine how it's learning, and if it's learning better and better, it's going to make improvements. If it's learning worse and worse, it's going to try to self-correct and make that better, right? So basically, this type of machine learning was inspired by the human brain, and it consists of connections or layers of artificial neurons, right? Almost like the human brain works. So it's very interesting. There's topics called convolutional neural networks and recurrent neural networks, CNNs and RNNs. These are ANNs. So I have a couple of videos on this. You can check it out on my channel. But it's very interesting. It's very much based on how the human brain works. So I have an 8-year-old son. When my son was a little baby, I could show him a picture of a cat and I'd say, "This is a cat. Okay, it's a cat. This is what a cat looks like." And then he would look at the picture and he's shaking and say, "Yeah, okay, this is what a cat looks like." And then I'd show him a picture of a dog. "Okay, this is a dog, and this is what the dog looks like." And your brain is putting together all of these different representations of what does a cat look like? What does a dog look like? What about a kangaroo? What about a worm? What about a bunny rabbit? What does this thing look like? And based on all of the characteristics of the image, that is a cat or a dog or a worm or a kangaroo or a bunny rabbit, or this could be an apple. This could be an apple, right? Like, you don't know what it is until you introduce the subject to the learning mechanism, which can be a human. In this case, it's an ANN, artificial neural network learner. Certainly a human being, a little baby. So you teach it what it is, and we'll see it in a minute why these things are important and how it works. So I will go ahead. I'll run this one. I'm not going to run the others because I just have a T14 ThinkPad. It's not very fast at all. Like some of these things, honestly, they take close to an hour to run. Some of these scripts take close to an hour to run. But the T14, at least in my case, it has a what's it called? Solid state drive, I think. So it's just pretty fast and runs pretty fast. This one ran pretty quickly here. But these things can take up to 30 plus minutes, 40, 50 minutes, 60 minutes to run. I'm not going to do this in real time because this video will go on and drag, and I don't think you want to see that. So I ran the first one. You can see here and here's the script. So TensorFlow, we have decode predictions, and I'm importing a couple libraries, image and image to array. So any kind of image that's imported has to be converted into an array of numbers, and the numbers, or the array of numbers, is the decoded representation of the image. Okay, so I'm looking or looping through all the items in this folder, and then we'll upload this code, and I'll upload all the files I'm working with too, so you can copy and paste this into your own environment and run it. So I have a giraffe, cat, apple, banana, and a bike. It looks like a mountain bike. Looks like a mountain bike to me. And I'm not naming it, right? So if I name this giraffe, if I name this cat, apple, banana, mountain bike, you could say, okay, maybe the computer is taking the name of the image and it's learning from that. I don't want to do that. I want to use a pre-trained model and just use something ambiguous, 1, 2, 3, 4, 5, and ask this algorithm to make a prediction on what the image is. So the first one says cheetah. Okay, and it's actually a giraffe, but I can kind of see how this gets to a cheetah. It has spots on it. Kind of looks a little bit like a cheetah, I guess. If I zoom in, if I control enter, okay, that could be a cheetah. I mean, not really. Like, I think you and I know that's not a cheetah, but the computer made a prediction. It says probably cheetah, 57% confidence. That's a cheetah, and this is an Egyptian cat, 54%. So this is interesting. Actually, I got the cheetah wrong. It's actually a giraffe, and I got the cat right. Let me go back here. Got the cat right, but it looks like an Egyptian cat. It's a little bit interesting, but it got that one right. Okay, so that apparently is an Egyptian cat, according to the model. Let me close this down and close this down, and then it says pomegranate. Okay, 29% confidence. We should probably have something a little bit better. We should probably say, like, at least if you're going to make a prediction, at least has to be 50% confident. This is okay. This is just the basic learning. We'll get into like everything that's going on here in a minute. So it says this is a pomegranate. You know what? I'll give you the benefit of the doubt. That could be a pomegranate. Kind of looks like an apple to me. I actually know this is an apple. It's not a pomegranate, but yeah, that could be a pomegranate. I'll give you that. And you're 29% correct, 70% incorrect. This says banana. Okay, so this one is correct. 76% correct. So that's a banana. I agree with you there. And this is a mountain bike. And again, I agree with you. Okay, so you got 3 right, 2 wrong. And the higher the confidence, the better predictive capabilities of this model. Okay, so let's go ahead and use a different technique. So that is just using a pre-trained model that has been trained presumably by TensorFlow, Keras. So these things, PyTorch, these have been around for, I think at this point, like 12 years or so. This came out a little while ago. Pretty mature technology. It's been around for a while, and these guys have created these models and set up all. This is all open source. It's all free. Some of the things I like to do is more like AWS, Azure, GCP, but you pay a lot for these technologies, right? Like, funny story. I'll keep it quick though. So I tried AWS about a month ago, and it was $900 to do one analysis. It took like an hour or so, and they charged me $900. And my credit card company saw this charge, and they flagged it as fraud, and they said, we're not going to pay these guys because this doesn't seem right. You paid $900 for 1 hour of analysis. And I thought, yeah, this is not right. I could do it for myself on my laptop basically for free, or whatever I pay for electricity. Electricity is pretty cheap. I can do it for close to free. And I don't know why they charge that much, but if you do have deep pockets, and you know you're a big corporation, you subscribe to these things, you can do this very quickly. So my laptop, it's kind of slow. If you run this on a big cluster of computers, it can run pretty quickly and pretty seamlessly, and you can get this job done pretty quick. So everything I do is open source. Pretty much everything I do is open source, and it's free. That's why I'm doing this right now. So that was the first step analysis. I'm not going to run the second one just because it takes so long. But what I'm going to do is go ahead and rerun the same type of process I ran before. So everything is looping through this folder. If I go over here, sorry, I've split screens. Yeah, so if I go over here, these are all the pictures I have on my desktop right here. So Ryan desktop pictures, and I have labels 0, 1, 2, 3, 4. Okay, so I'm going to loop through those labels right now, and I'm going to run a bunch of epochs. An epoch is basically a looping process. Like I told you before, We have the input. This is the input layer. That's the picture. And the output is the prediction. The epoch goes through all of these things right here. Okay, so we have a forward propagation. We have a loss calculation. We have backward propagation and iterative learning. So just like the human brain learns, this is an apple or this is a pomegranate, two different things, right? They could look similar, but they're different. This is a cat. This is an Egyptian cat. This is a cheetah. This is a zebra. And this is a giraffe. I want to see a picture of a giraffe, and I want to see, sorry, what was the other thing? I wanted to see the bananas, yep, the bananas, and then the mountain bike. So that's what I want to see, and that's what this process is doing. And so this right here is a pre-trained model. It goes through all the training of the images and the memory of this model, how it's been trained and saved, and they pickle it. I have a video about pickling. You train the model, split, train test, right? Save it. And this is going through the saved model. It's exactly what it's doing. And then this right here is going through a model and epoching 25 times. I think it comes from, where is this? Oh yeah, it comes from here. So the number of epochs is 25. And if you increase this, you can increase the learning rate. So I've got a couple videos about this, like how well does the model learn? How do you increase the efficiency of the model? How do you improve the learning rate of the model? How many leaves you go down if you're on the random forest classifier or regressor? How far do you go down? When you stop it, there's a stopping rate. There's rates to learning. Just like a human being would learn, you can learn a little bit faster, a little bit slower, a little bit deeper, right? This is deep learning. And we're just saying, just loop through this model 25 times, okay? So I'm not going to run it. But the accuracy, you can see here, at the beginning, it's 50%. Then it jumps up to 100%. So it's learning very quickly. The loss goes from 1.5 to 0.58 and then steadily decreases to these pretty small numbers. When you have exponent of negative 0.4, this is a very small number, guys. This is very tiny. Kind of bounces a little bit here. That's okay. That's okay. But we're still getting accuracy of 1%. So it starts to jump up very quick. It hits an accuracy of 100% or 1.0. Yeah. So basically 100%. And then here's the loss factor here. And the value accuracy is pretty tight. And the value loss is pretty de minimis over here, okay? So I'm going to assign class names. So this is just like a human being would learn. If I say, hey, my son, here's a picture of a giraffe. This is what a giraffe looks like. It has a big neck and it's sticking out. Let me show you over here. We'll go back. So this is a giraffe. It's a large animal, probably 20 feet tall, long neck, okay? This is what a giraffe looks like. The name is giraffe, and that's a giraffe, okay? It looks a little bit like a cheetah, but not really a cheetah. It's kind of like a little bit different. So I'm telling this machine now what this thing looks like. This is a cat, okay? The second one is a cat. This is an apple. So the third one is apple. Then we have bananas, and then we have a bike, okay? So I'm telling you how to learn. So I have a pre-trained model in the first example. The second example, I'm telling you what these things are, okay? So this is not negotiable. This is not arbitrary. I'm telling you what the thing is. What is this image? Is it an animal? Is it a giraffe? Is it a cat? Is it an apple? Is it a fruit? Is it a banana? Is it a bike? Is it something you can ride? Okay, so the machine is learning. Now you see, okay, this is a giraffe, and I'm confident 100%. And then it says giraffe, confident 100%. I think this looks a little bit weird, personally, because I think the second one is actually a cat, but that's okay. So we got 100%, 99%. I think this machine made a mistake. That's okay. The first time it said cheetah, and it was 50% confident. Egyptian cat, 54% confident. Then we had pomegranate, about 30% confident if you're rounding. Then bananas, pretty good accuracy there. Confidence is like close to 80, 60, 76%. Yeah. Then mountain bike and 73%. Now, when I told that what to learn, and this is how these things work. Like Google used to hire these people and say, yo, this is a giraffe. And anything that looks like a giraffe, you have to flag it as a giraffe. People would manually go into systems and say, this is a giraffe. This is a cat. This is a Honda Civic. And this is a Honda Civic CR-V. And this is a BMW Bavarian Motor Works car and everything. Like, people go in and describe what these images are so a computer can learn and say, okay, so this is what a BMW looks like. This is what a circle looks like. This is a giraffe, and this is a cat, and this is a dog, and this is a bunny rabbit, and this is a bird, okay, or whatever the thing is. Like, people had literally identified what the thing was. Sorry. And this is how computers originally learned how to classify all these images. Back in the day, you had to manually click through it and describe what you were looking at. Then the computer could learn that thing, and it would remember it just like a human being would do. If I tell my son, hey, this is a bike, and this is a cat, and this is a mouse, like, my son will learn, okay, that's a bike, and that's a cat and a mouse. I got it, Dad. I got it. I know what this is. I got it. I'm on top of it. Right, so here's a giraffe. And that's 100% correct. The second one is actually cat. So I'm a little concerned about this, but that's okay. I think the computer made a mistake. That's okay. We can handle it. We can say anything is not 100%. Let's loop through again, and we'll circle back, and we'll get that next time. That's an apple. Banana is 100%, and bike 100%. Okay, so this thing got it. This thing has a deficiency here of about 1%. We can say, hey, anything it's not 100%, let's go back, and we'll recalculate that. We'll take a second look, or we'll spit that out into another list, and we'll take another look at that one, right? So that's fine. I'm comfortable with that. So now let's get into natural language processing and sentiment analysis. So I have some files over here. We just saw the images. I have files. I'm going to do this 2 ways for you guys, and I'm sure there's so many ways to solve this problem. I can't even think about it right now. So I have Word documents, okay, and I have text files, and each one is the same thing. I looked at a couple articles on this thing right over here. It just pops up. I don't even know what this thing is. It just comes up here. So we have United Healthcare CEO, shooting case, not a slam dunk. Wrong answers, plane makes emergency landing. Rob McNally, Ryan Reynolds. And then Apple went public 44 years ago. That's interesting. What would your $100,000 investment be worth today? We could figure that out. I think I have a couple of videos on stock analysis. I definitely do. Okay, Roblox, how to appear offline, and back to United Healthcare. Okay, so that's the only reason I bring this up is because that's where I got these articles from. So I went ahead and opened these files right here. So if I go here, YouTube video, a pill to treat alcoholism, and why aren't doctors prescribing it more? So that's one, and I have a Word copy, and then I have a text file, okay? All you have to do if you want to save Word as a text file, over here, file, save as, this PC, and then you go down here to file type. You can save it as a PDF, you can save it as plain text, you can save it as plain text.txt. This is probably the first type of file ever created by Microsoft. I'm not sure. I didn't validate that, but I did a lot of VBA programming back in the day for Excel, Word, Access, Microsoft Outlook, even PowerPoint, things like that. So anyways, you can create Word documents, and you can create text files, and this can contain the information for that news document, or whatever it's called, that news thing over here, news article, whatever this thing is. Okay, so that's why I got these things. So I got document files, and they have text files. It could be a PDF, it could be anything you want, right? Okay, a pill to treat alcoholism exists. Why are doctors not prescribing it more? So I want to loop through all the files in this folder. I'm going to share all this stuff with you guys. I'm going to share the image files that I just shared with you, the drafts and the cats and all that stuff. I'm going to share these files too. So we're going to go ahead and loop through a bunch of Word files and a bunch of text files and see what is going on here. And again, we're looking at epochs. Okay, so this is the iteration for the processing, the input and the output layer, the processing of the data, the looping. We're going to now analyze this multiple times and let the system, the ANN, artificial neural network, go ahead and make a recommendation about what are we actually looking at here and what does it mean. Okay, so just like the image files, we're trying to make predictions here. We see here, a pill to treat alcoholism exists. Why aren't doctors prescribing it more? Almost 12 million people in the U.S. struggle with alcohol use disorder. defined as more than 4 drinks per occasion for women and more than 6 for men. Katie Lane was blacking out several times each week from drinking alcohol. So if I go over here and just open up this document, okay, we're getting just a quick summary. Okay, so it's not word for word. It's not just copying the first 50 or 60 words from a document. It's actually summarizing it, which is nice. It's actually summarizing a document, and that's telling me, okay, is this positive or negative? This is kind of a negative article. So I get it. So alcoholism is bad. People shouldn't be alcoholics. I think I heard once before 1 in 8 people in the United States actually is alcoholic, defined by having 4 drinks per night or 6 for men. Is that the definition? Something like that, right? So it's actually summarizing the contents of that Word document, and it says this is bad. So alcoholism is bad. Okay, I agree. This is correct. Second one, football coach among 6 people killed in fiery New Jersey car crash, right? So I live in New York City. So it's a local article. They're talking about New Jersey. 6 people killed. This is negative. Absolutely agree. This is a negative article. 0.92. I think this should be a little bit closer to 1.0. So the first one was about alcoholism, and this is negative. Second one, 6 people killed in the fire crash. I would think that would be 100% negative. There can't be too much positive about that. But it didn't round up to 1.0. It had 0.92. So it might be something in that article that is triggering the computer. Let me open this up real quick. Triggering the computer to think like it's kind of highly negative, but it's not totally negative. Police are formally called to identify the victim. I think that's a little randomness, and I think the computer actually got a little bit distracted here by the randomness. So I would say that's it's okay. It's pretty close. Should be probably 1.0 negative, but it does get a slight non-negative rating here. So Susie Orman was blunt words on Social Security for retired Americans. Doc. Okay, this is 0.98. Social Security recipients will receive a relatively small increase in their paychecks beginning in January. The adjustment will be 2.5% to take into account for inflation and what people who continue to work while collecting Social Security benefits may also see reduced benefits, presumably, right? So 0.98. Yeah, that's negative, right? We have a lot of inflation. We're living in a high inflationary environment right now, and it's only Social Security benefits are only going up 2.5%. I would say that's negative. I would say that's spot on. The most extreme rogue wave ever recorded in the Pacific Ocean reveals astounding details. Okay, statisticians estimate that such an event only occurs once every 1,300 years. Wow, I did not know that. So I learned something new. Euclid wave is significant lies not just in its height, and this was positive. So this one for me, this is a little bit of an outlier, like that cat thing that we saw before. It said this is an Egyptian cat. I thought it was just a cat. I didn't know the difference, and then the computer said this is a cheetah. I'm looking at it. It was actually a giraffe. I know for a fact it's a giraffe. I know that cheetah looks like that. But so this is positive. So I think the most extreme wave probably should be neutral or maybe negative, but this says 100% positive. So the computer could be getting confused again. We could dial this in. We could retrain it. We could do a couple different things here. Just trying to think, like, why would this say 100% positive? But it could be subjective too. Maybe like a really high wave is a positive thing. If you're a surfer and you love waves, yeah, that's a positive thing, right? But for me, I'm not a surfer. I would think, okay, maybe this is kind of like a neutral thing or a little bit negative, but the computer says it's positive, and it's arbitrary, right? This is somewhat subjective. It's somewhat arbitrary. That's okay. I'll let you go. I'll let you have this one, okay? Tragic death of 34-year-old Disney influencer raises the alarm about the dangers of living with food allergies. That is a negative. That should probably be 100%. Pretty close to 1.0. It's actually, it's not quite 1.099, but I would say the machine is doing its job. It's doing pretty good here. This one looks a little bit weird to me. I would say that's neutral or maybe negative. That one I would call that out. But all these others are spot on. Okay, so it's working. So we looked at two great illustrations here of how ANNs work, right? I'm pretty happy with the results, but let's look at one more. So we saw the images, we saw the documentation, not the documentation, sorry. the news stories, reading through Word documents, right, and text files. So let's look at one more. I'm a finance professional by nature. I graduated with my MBA in finance 21 years ago from Johns Hopkins. I've worked in finance for many, many years. Worked on Wall Street for a very long time. So let's look at a finance example here. So again, I'm sharing all this code with you. You can copy and paste it. I'll give you all these files here for the images. I'll give you all these files here for the documents. I'll share all that with you. And of course, all these things I'm doing, guys, everything is designed to be very general, very open. You copy paste the code into your own environment, run it, and then you have your own documents that you read. You have your own text files that you analyze. You have your own images that you analyze. All right. And you can do this on anything. I'm trying to give you the backbone here, the foundation to do whatever you need to do on your specific data. So I'm just showing you basic examples. I'm trying to illustrate the point of how this works. But I want you to take this and to run this on your own specific data and get the results that you need. That's the whole point of this thing. Okay. So my files are mine. I'm sharing it with you. Some of these things are just kind of silly examples, but I want you to run your analysis on your documents, on your data, your images, your Word documents, your text files, and get the results that you need to answer the questions that you need to answer. That's the whole point of this thing, right? So let's switch over to a finance example. Right now, I'm going to import some historical data. And this is going to be, I think this is, oh yeah, I'm looking at the wrong thing. Okay, so this is the finance example. Last one was the Word document. So we are looking at adjusting closing price for Apple. I think this is for Apple. Let me see here. Where is it? And simple moving average, 10-day average, right? I'm looking for the Apple. Where? Oh, yeah. That's what I thought, Apple. So again, so this is very generic. You can change this to whatever you want, guys. This can be Microsoft, Coca-Cola, Johnson & Johnson, any stock you want. You just put in that ticker, okay? And the amount of time that you go back, in this case, is 6 months. I like 6 months. I did this in several videos. I think 6 is really good. I think if you go back 12, that's okay too. That's fine. If you go back longer, 2, 3, 4, 5, 6 years, I don't think it makes a whole lot of sense. It's just too much information. What was happening 6 years ago? That's before COVID. Right now, it's the end of 2024. 6 years ago, before COVID. Before COVID, it was a different world, right? Things were very different back then. I don't think you can compare the post-COVID world to the pre-COVID world. 1 year is fine. 6 months is fine. I don't like to go back too far with these things. If you want to go back 10 years, you can go back 10. Really, it's up to you. Put number of months 10 times 12, 120. You can make this 120 months. You put this in. This is a variable. You choose what you want. I think 6 is good. You can put 12. Between 6 and 12 is fine. After that, I'm not gonna speak about it. I don't think you should go back too far in time, because what was happening 10, 20 years ago, even if you think about 50 years ago, it doesn't matter in today's day. It doesn't matter what's going on 50 years ago. People are so focused, they're hyper-focused on what's happening right now today, what happened yesterday, what's happened 1 hour ago. That's what people care about. Recency dominates, right? Like primacy, people don't care about it. They don't care about primitive things. They just don't, okay? And I'm on board with that. So we're looking at Apple. We're looking at the adjusted closing price right here, right? Adjusted close, simple moving average of 10 days. RSI, resistant, oh God, what was that? Resistant stock impact index. Geez, I did a video like that 6 months ago. I forgot so many videos and I forgot. But RSI is another factor that you can analyze, right? So we're pulling back all the information and again doing an ANN analysis, so artificial neural network analysis, and you can see the same thing we saw before. Here's the loss, right? So loss should be decreasing if we're doing this right. 0.06, 0.02, starting at 0.02, 0.01 goes down to 0.01. We get to 0.0109. Okay, it's going down a little bit. 0.000, 0.0089. So this is getting better and better. 0.096. So this is a loss. This is the information loss that we're getting. The mean average error should be reducing to. So if we go here and look at the beginning, mean average error is 2%. We go down after 50 epochs to 0.08. So we went from 2% to 0.8%, right? I think that's what that's. So the loss is decreasing. The mean average error is decreasing. Sorry. So these will correlate very highly right here. And then we can see what the average what the actual price is and what the predicted price is based on this ANN. Okay, and this chart shows us right here. And the final root mean square error, RMSE, is 5.85. So it's pretty low, not exactly zero, but it's pretty close. So I think the model is predicting pretty accurately. And I've got a couple of videos that describe how this works. So I think the model is predicting very accurately, and the mean average error, MAE, is 5.0. So again, it's pretty low. It can be way higher, guys. It can be way higher. So I think this model is learning and predicting, just like the first one. We saw the image prediction. We saw the document summary and prediction of positive, negative, neutral. So examples of that. And because I'm a finance guy, I gave you a finance example too, but you can use ANNs for anything, guys. You can use it for any kind of predictive capability, any kind of neural network processing or transaction or comprehension. What are you trying to learn? What are you trying to do? What are you trying to understand? You can dump that to an ANN and go ahead and get the model to make predictions for you. So that's pretty much it. I just wanted to take you through the topic, the subject. This is pretty cool, I think. We saw 3 practical examples. There's so many things you could do. I could create a video that goes on for hours and hours. I could talk about this stuff literally all day long. I could do lectures about this. I could create a whole college course about this probably, like if I had enough time. But that's it. I gave you 3 practical examples I think represent what's possible here. I showed you the inputs, the outputs, and then I want to give it over to you and let you run your analysis and see what you can come up with, right? That's the goal here. So I will post all the code. I will post all of the images. There's 5 images here. I'll post those files. We have 5 Word documents and 5 text files. They are basically exactly the same thing. And you have this financial model prediction into the future, what Apple, the price of Apple stock will be into the future. Okay, so hopefully that was informative. Hopefully that was enlightening. I learned a little bit doing this video. I hope that you learned a couple of things in the process as well. Okay, thank you so much for your time. Enjoy the rest of your day. Bye.